Welcome back to my channel again, and today we are going to continue on what we started on logic gates. And if you have not watched that video, please go back and watch it before you come to this one. So just to make sure that everyone is on the same page, let me give you a brief introduction. What are logic gates? Logic gates are basic building blocks of digital circuits. Now, it is an electronic circuit with one or more inputs but one output. Now, the relationship between the input and output depends on certain logic, and hence the logic gates. And in this we have all categories of logic gates like AND gate, NOT gate, NOR gate, XNOR gate, etc. So last time we talked about NOT gate. Now today we're talking about AND gate. So what are AND gates? Now for this project, we're gonna use a few things, and we're gonna use 2 transistors, 220 ohm resistors. We're going to use switch buttons and a 9-volt battery. Now I just happen to have the 9-volt batteries here, and I have the transistor here, this one. I just see this one. I'm gonna use 2 of them. I just need to get it out of where I put it. So yeah, I'm going to use this transistor, 2 of them actually. I have 2 of them here. Yeah, and I think I've already in the previous video told you the orientation of this. If you put it this way, this will be a VEE. This will be the base. This will be VCC. So if you put it this way, yeah, I don't know what you can see. This is really tiny. Then this will be the VCC, base, and VEE. It depends on the orientation. And we have the LED that we are going to use, this one. And the longer leg is the positive, the shorter leg is the negative. I've already told you in the previous video. And we're gonna use the jumper wires. We're gonna use the breadboard to do this. So what does this circuit do? Now before we go there, I'd like to show you this diagram. Just getting ahead of. I don't know whether you can see this. Oh, come on. It's much clearer. No, this is just taking a wrong diagram. I'm sorry. This one. I've drawn this diagram to illustrate this gate. And as you can see here, we have 2 transistors in a series, and then we have on top there the VCC, and then we have transistor 1, transistor 2, and this is circuit path, the current path. Here we have the truth table for this AND gate. Okay, so in this truth table we have the inputs, like 0 and 0 will give you a 0, 0 and 1 will give you 0, 1 and 0 will give you 0, only 1 and 1 will give you an output 1. Actually this means low is low, low, high is low. Now high, low is low, 0 means low, 1 high is high. There are inputs here. So this is what, and then down here we have the circuit simple. We have 1 and 2 inputs, A and B, and this is the output. This is simple for AND gate. Okay, so I'm bringing it closer for you to see. Okay, so 1 and 2, or A and B, is the same thing, and that's the output. This is simple for it, and this is what we call a truth table. Truth table. This is a table for this circuit. So we can see in this, I have to keep looking, guys. You have the ground here, you have the transistor, the base. This is a base. Yeah, this one, input from the base, another input from the base, and the resistors are here. Okay, so what does this circuit do? According to the truth table, you can see whenever there's an input, only one input, means if A is high and B is low, then the output is going to be low. If both are off, the inputs are off, then we are going to be having an output which is off. And if we have high and low, means there's one input and the other one is off, we're going to have off. Unless both are high, both inputs are, their inputs are high, only then you can have an output. So I have constructed the circuit, because it's quite a task to do it under the camera. So I'm going to show you this AND gate, how it operates. So here is the stuff that I've constructed. It's quite, you can see it's quite complex. Just hold on a minute. I have to link it up, guys. Yeah, so I've linked it up. I'm trying to hold it for you to see, and I don't know how I can make it. Okay, here is the circuit. You can see the jumper wires all over the place, quite a mess. And we are having two transistors in between there. I don't know how I can point them to you. I'm trying to make sure that these wires don't come off because they're very loose. From the back here, I don't know, you can see these are the switches. These two are the switches. I put two switches, and here where my finger is pointing, we have one transistor here. You can it's just sandwiched in between these jumper wires. I don't know whether you can be able to see it right there. How can I point this out? See, my finger is a bit blocking. Just 1 minute. Can you see this? Can you see where the pen is going? That is a transistor. Another one is here. I'm trying to see, guys. Another one is there. Let me put it this way. Yeah. Can you see that? Can you see this? That is a transistor where the pen is pointing. One transistor is there. Another one is there. And then this is an LED. Then we have this resistor here, and we have two resistors behind here, just here, which I've connected. You can see the resistors are connected. Two resistors are connected from the positive rail. These two, 1 and 2, they are connected from the the positive rail to the switches. And this one, the one behind here, I'm trying to make it for you to see. The one in my end here is connected from this jumper wire, which comes from the positive side on the other side to this, to the LED, and to the base of the transistor. Now this wire has just come out again. Just hold on, guys, I have to connect it. It's a really crazy thing with this wire is very tiny. So I'm trying to put it inside. I don't know whether that's gone or not. Yeah. So now see, the working of this circuit is like this. Whenever there's one input through the base of the transistor and another one is off, the LED will not be on. So let me do this. See, I'm putting this switch on. Nothing is happening, right? That means 0, 1 high and 1 is 0. Okay, let me repeat. I just have to hold it actually properly for you to see. Okay, another one is here. Let me put it on again. Put the current through the base of the transistor. I switched it on, but there's no output. That means on, off, or off, on. There's no output. And now both are off. Okay, still there's no output. Now I'm gonna press both, means A and B are on. Then we see what happens. See, it's on. The transistor is on. Okay, see, the transistor is, the LED is on. That means the current is flowing through the base in both cases. But one, no. One is this side, no. But both, yes. Okay. This means 1 and 2. AND gate. That's how it's called, AND gate. That's where the name comes from. So the transistors here are acting as switches for this particular circuit, and that's how it works. So LED is an output. That's an output, and if I release one like that, it's off. If I press it again, it's on. If I release this one, it's off. If I press it again, it's on. Okay, so this is how this circuit works. I'm trying to press both on, so that now I press both on continuously. They're both on, and see. So guys, this is the AND gate. So for this also we needed a 220 ohm resistor to prevent this LED from burning out. So this is what AND gate is. There has to be 2 inputs for an output to be on, and that's the logic. That's why I call AND gate logic. Now there are areas of application of this logic. Sorry guys, I'm sweating salty. Like we use this in digital electronics, data transmission, digital measuring equipments, alarm circuits. Like for example, in digital electronics and data transmission, it's used in to allow or not to allow data to go through a channel from point to point, or from point to multi-points or multi-point channels. Examples like we have this in a like a optic Viper or copper channels or wireless in computer buses or storage devices where they are used. So they are very useful. You can see the area of application is wide. Yeah guys, so this gate is called hand gate, and the other one we did was not gate. Now next we'll see whether we continue this series and we'll do another gate. But for today, this is all that I wanted to bring to you. So you've seen the hand gate, I've shown you everything. Now if I have to repeat again, I've shown you the 9-volt battery, the jumper wires, the red wire of the battery connecting to the positive. You can't see it. And this one is connected to the negative. This one to the negative, this one to the positive rail of the breadboard. Yeah guys, so thanks for watching. Hope to see you again in the next video. If you are not subscribed, please consider subscribing to this channel as we try to dive in and bring you more and more interesting material. Okay, thank you guys, bye for now. Please subscribe again, share and like. Bye.